Ben Shneiderman, thank you so much for being here. Would you describe what you do, or what is your title right now?
Thanks for inviting me here. I've been a professor at the University of Maryland for 40 years, and I'm now officially retired, but pretty busy and working on lots of projects as I go. So when I came here, I was a computer scientist working on databases and file design and optimization and indexing techniques, very techie stuff, and that kept me going. But I always had a somewhat different outlook and was interested in the psychological aspects of people using technology. And the early work began by studying programmers and how programmers did their work, and did psychological studies on groups of programmers to see if, for example, more meaningful variable names improved the capacity to repair a program or find a bug, and they did. Or simple things like indentation strategies actually also mattered as well. Modular design and choice of programming languages, all those were important issues. And so I got quite into the psychological aspects of doing this kind of research. And by 1980, I wrote a book called Software Psychology, which was kind of a bold step and a sort of far out idea. The publisher thought they'd take it and do something with it. And it turned out that at the time there were 2 computer science book of the month clubs, and both of them took it as a selection. And so suddenly it gained attention. And so that was very satisfying to see that there was interest. I was already building a community of people here around the Washington area who were interested in these studies of programmers, because personal computers were just getting started in those days. It was still a new idea. And in 1982, we arranged a conference in Gaithersburg, Maryland. And that became a historic moment, because we hoped to bring 200 or 300 people together who were interested in these psychological studies of computing and programmers. And we had 906 attendees, which just woke things up in a wonderful way. And so that led to the formation of the SIG-CHI group, the Computer Human Interaction Group, which that conference, I'm very happy to say, keeps going at 4,000 people a year around the world. And it spawned within their group, they have 26 smaller conferences on a variety of topics, such as automobile user interfaces, game playing interfaces, mobile devices, social media, and so on. So for me, there's a great satisfaction to have seen that trajectory of success for this topic. This marriage of disciplines, as I called it, worked out pretty well. And there was the twins that were born with a research discipline of human-computer interaction and the professional work now called user experience design. So that's gone very well. And so it's a satisfaction for me to see that happen. Here at Maryland, I continue to do work focusing more and more about the design of user interfaces for personal computers, and then laptops, and then eventually mobile devices. So we did a lot of things here that were quite different, but have become important. So if I focus just a few of them, the idea of getting information off of a computer was well established by 1980, but it was kind of awkward. You had to type numbers or commands, get a long menu of choices, type number 17, and so on. And one day, while we were working on a project for the Holocaust Museum, which was being formed, an electronic encyclopedia, the text on the screen was information, and then the choices were repeating a series of names. And I asked Dan Ostroff, was the grad student working with me in this building in Hornbeck Library, and could we just make the names highlighted and selectable, and you could click on them? And he did that. Now, in those days, mouse was just beginning to be formed, but you could have arrow keys and they would jump and you could select on that. And so that's the way the idea of the visual representation of the link began. We did a series of controlled studies about different ways of doing that, including the color. So we tried one where the links were bright red, and while people could spot the links easily, they were less good at remembering the text that was there. It was too distracting. So the light blue that we chose is what Tim Berners-Lee followed and copied from us. So that work was 1985, 4, 5, 6, and we began to publish about that. And in 1988, we did the now famous Hypertext on Hypertext project, which was for the ACM, the Association for Computing Machinery. And it contained the full text of the 7 articles in the July 1988 issue of the Communications of the ACM. And those articles were from the 1987 Conference on Hypertext. And that was a great success story. And it was that item that Tim Berners-Lee, who we knew well, was a researcher in hypertext, he saw that and he cited that in his spring 1989 manifesto for the World Wide Web. And from there, he implemented that. We called them embedded menus. He was clever enough to call them hotspots or links. And that went pretty well. And by 91, he implemented that. And by 93, it was moving pretty far out, pretty widespread. So while the idea of the link goes back to 1945 to Vannevar Bush, and others made important contributions, like Ted Nelson coined the term hypertext and hyperlinks. But our contribution was the visual representation of the link that was highlighted within a paragraph, and you could click on it and go somewhere or go back. So the back button, the history stack, those are all
part
things
of that as well.
that we did.
Really interesting,
Yeah. So hyperlinks are one of those great little ideas that has a vast impact and a great satisfaction that was done here at the University of Maryland.
That's awesome. Wow. Thank you for the little the wrap up of your biography. Okay.
So the hyperlinks was an important part, but we were very much intent on making systems that were usable to people. And I developed the theory of this, which I called direct manipulation, that the objects on the screen should be visible to you. They should be touchable. They should be selectable. And so that pushed us down the road to working on touchscreens. So by 1987, we were deep into touchscreens for public kiosks. 86, 85, we built kiosks for museums. And those early studies of museum kiosks in Washington and New York were also very influential and reinforced our belief that visual representations and direct manipulation, touching on a map, was a very powerful idea. And so we began to see if we could make a keyboard. And at that time, the touch screens required 1-inch square buttons to make them touchable. And we made a 9-inch wide keyboard, and we measured the typing speed. And then we made a 7-inch and a 5-inch. And then we got it down to 3 inches. Now, 3 inches in those days was kind of tough because the keys were about a 1/4 inch wide. And so we had to develop a more precise way of selecting. Most touchscreens, all touchscreens at that time, operated by what was called the land-on principle. When you land on it, it selects it. And we found that that often led to incorrect touches. But if you touch the screen and allow users to wiggle their finger around, give them a little cursor above their finger, and then let them lift off to activate, we could get to high precision. And we actually showed that you could type on a 3-inch keyboard. Now, the reviewers of that paper didn't believe that we could accomplish this.
Really?
And it took a video, which is on our website, to convince them that actually it was doable.
That's interesting,
So the touchscreen was another part of this idea of direct manipulation, of thinking of the screen not as a bunch of text that scrolls by, but as objects on the screen. Now, this was very much in harmony with the graphic user interface ideas that were developing by 1980 in the Xerox Star. Maryland was an early leader in using the Xerox Star. We had a big installation here in close connections with the Xerox Palo Alto Research Center. And as you may know, Mark Weiser was one of our faculty members. He then went to Xerox PARC. He was a collaborator with me, and he went to Xerox PARC to become the head of their research activities, and developed the notion of what he called calm computing, and wrote a very influential article in 1991 in Scientific American. And those ideas grew out of what happened here, and he carried it further. So Maryland's had a very profound influence on a variety of potent technologies. We continue to do many other things after that. For example, the idea of e-commerce and shopping and selecting from thousands of choices also came from our work. And we call them query previews, and they eventually generated the faceted search or faceted menus where, on the side of the screen it says, do you want red, green, blue, or orange? Do you want, $10 to $20, $20 to $30, or these many, many choices? These parallel menus were an idea that we developed here for a project supported by NASA.